Hello class, this is the third video for March 25th, focused on section 5.6. I have 3 examples. It might take me 2 videos. The first is growth, the second is calculating compound interest, and then the third is decay. For this example, I have typed up the word problem for you. We're starting with a culture of 500 bacterium, and we're able to determine that the growth rate is 40% per hour. So the first thing we're going to do is come up with a function that we can use to answer the other 2 questions. In this entire section, we're using the same formula for all of the different applications that we have, and it is this. And we're specifically looking at k being larger than 0. For the decay examples, we'll have k be a negative number. So p naught, or this little sub-0, is our starting amount. K is the rate of growth, and t is the time. And then p of t is how much of the item that we end up with. You should see that all in the slides. So this is the general formula that we're going to use. What do we know? Well, the problem has told us that the starting amount is 500. So we know that p naught, or p sub 0, is 500. We also know what the rate is. The rate is 0.4. We always take decimal values, percent values, and write them as decimals for our math problems. So let's put together what we have so far. We can say that for part A, we have the amount of bacteria after a certain amount of time will be 500 times E raised up to the 0.4 times T power. So that's our answer to the first part. For part B, we're wanting to know how many bacterium there are after 10 hours. So we're just plugging in T equal to 10. So P of 10 is 500 E to the 0.4 times 10. You can just plug this into a calculator and you're going to get around 27,300. I think this was rounded up. So that's part B. Part C is the part that's a little bit more challenging. We want to know after how many hours we will have a certain bacteria count. And so we're solving for T, which is up in the exponent. So we want to know when there are 80,000 bacteria, we know that the starting amount was 500. The rate is 40%, and that T is what we're solving for. So this uses the examples that we had in the previous videos. We want to isolate the exponent before we take the log of both sides. So the first thing that I'll do is I'll divide both sides by 500. So that'll give me 160 equals E to the 0.4t. Now we can take the natural log of both sides. We want to use the natural log because we've got an E as our base. And the nice thing here is that the natural log and E will cancel each other out, and we'll just be left with, 0.4 times T and natural log of 160. And then we can divide both sides by 0.4 and plug this into a calculator to get our final answer. So if you plug this into the calculator, you're getting that T is approximately 12.7. So that means that the bacteria level reaches 80,000 in about 12.7 hours. Okay. For our next example, I'm going to do one that's right off of your homework. I'm going to do letter F right here, the very last one that's from your classwork, sorry, from your classwork assignment. We know that it takes 46.2 years for however much money we invested to double. And we know that after 5 years from however much we invested, we're having 19,500 and some dollars. And so we're trying to, again, get back to this original equation that we had. We don't know what K is, and we also don't know what P naught is, what the original amount that we invested was. So let's start by finding K. I'm going to use the letter I for our initial investment. So we know that after however much time that it doubles, we would have 2 times I left over. Oh, we know that the doubling time. Sorry. We know the doubling time is 46.2 years. If I divide both sides by I, I'm just going to end up with 2 on the left-hand side. So this really simplifies the problem that we have. And in fact, you'll see a section of the book where it says when we're looking for the doubling time, we're just going to write the equation in this way. So I can take the natural log of both sides. Again, I'm going to take the natural log because I have a base of E. I'll write this as 46.2 times K. And then the left is just natural log of 2. And the right is 46.2 times K. And then we can divide both sides by 46.2. And then plugging this into the calculator, I get that K is about 0.015 or 1.5%. Okay, that's good. So we can use that now to figure out what the original investment was. So let's find the initial investment. Going back to our original equation, we now can put 0.015 in for K. And we'll use the fact that after 5 years, we know that we have $19,552.82. So I'll write this on the left-hand side. P naught is what we're trying to find, how much we invested to start. And I'm going to put 5 for the time, because it's after 5 years. So multiplying these two numbers together I get e to the 0.075. And then I can divide both sides by that e to the 0.075. And then plug that into the calculator. And we get that the original investment was about $18,140.